question is about double slit interference from October-November 2017, paper 22, question 6. A. Interference fringes may be observed using a light-emitting laser to illuminate a double slit. The double slit acts as two sources of light. Explain, I, the part played by diffraction in the production of the fringes. Before answering this question, I'm going to bring back your notes. As you remember, this is a light source with a wavelength, and this is a screen with two slits or opening. As the light passes through this opening, it's going to diffract. So diffract through this opening and diffracts from this opening. This light is split into two lights. They are identical. They have the same wavelength and frequency. Therefore, they are coherent. The coherent light waves combine right here where there is a interference. Constructive and destructive interference occurs when crest from one light wave crosses with the other crest from the other light wave, producing constructive interference. And when crest from one wave intersects with the trough of the other wave, creates destructive interference. As a result of the interference is going to be observed on this screen here, some bright and dark fringes. The bright and dark fringes are the result of the interference between two coherent waves and also known as superposition. As a result of the superposition, the resultant wave will be projected on this screen in form of bright and dark spots or fringes. After this quick reviewing, now I'm going to write the answer for these questions. When a light passes through the two slits, it spreads out, then superpose. The second question, the reason why a double slit is used rather than two separated sources of light. Double slits are used to produce two coherent light waves. Question B, a laser emitting light of a single wavelength is used to illuminate slits S1 and S2 as shown in the figure 6.1. An interference pattern is observed on the screen AB, and the separation of the slits is 0.48 millimeter. The slits are 2.4 meter from AB, and the distance on the screen across 16 fringes is 36 millimeter, as illustrated in the figure 6.2. Calculate the wavelength of the light emitted by the laser. Basically, in this diagram is showing a laser with a single wavelength, and here is the double slit screen. 0.48 millimeter is the A, that is the distance between both slits, and D is the distance between both screens, the double slit and the screen at which the fringes are going to be projected. And on this screen is not showing bright, dark, like we usually work on this type of problems, but instead is showing this diagram. In this diagram, let's assume that this bar is the dark and this one is the bright. So here will be the dark, bright, that supposedly should be in this direction. So let me list the numerical values this problem has provided. So here is the wavelength of the laser, we don't know. A is the separation between both slits, which is 0.48 milli. So milli, the multiplier is 10 to the minus 3 millimeter. D, the distance between both screens, which is 2.4 meter. And X is the distance between two consecutive bright fringes or two consecutive dark fringes. So let's determine the value of X. I'm going to erase this bright here and determine this is D, dark, and this is dark. And the distance here is 36 millimeter. So in this length, we have 16 fringes. So since we are working with the X between two dark fringes, so let's see what happened here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So which means the X is 36 millimeter divided by 16 dark fringes. So this is equal to 2.25, 36 divided by 16, and milli here is 10 to the minus 3 meter. So I'm using the formula for double slit interference. So doing my substitution, this is A, this is X, and this is D. 0.48 EE negative 3 times 2.25 EE negative 3 divided by 2.4. Before I write this down, you need to look at the unit. So here is in meter. So it's not millimeter, it's in meter. So we need to convert this number into scientific notation. So the decimal is right here, and I'm going to move the decimal between 4 and 5. So 1, 2, 3, 4, 5, 6, 7. 4.5 times 10 to the negative 7. So the total marks for this question is 3 plus 3, 6 marks. A pretty straightforward type of question.